Hey folks, welcome to the NCEA Level 2 probability paper from 2024. If you're joining us for the first time, the way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. Now the best way to watch this video is to pause the video at the start of each question and then try the questions out by yourselves and then unpause the video just to see how I go about answering these questions. So without further ado, let's get started. Alright folks, so for question 1, what we've got here is, what is it, working including diagram should be shown for all parts of question 1. Okay, so looking at question 1a, we've got normal distribution and mean of 10.8, standard deviation of 3.2, blah blah blah. Find the probability that chosen person is between 6 to 10.8. Okay, so we're looking for probability of 6 to 10.8, and what we're going to do is I'm just going to put this as a little graph right there. 10.8 is here and 6 is somewhere here, so the zone I'm going to be looking for is this. But what I'm going to do is I'm going to do this in the calculator, of course. All right, so what I'm going to do is I'm going to head down to the stat mode and go into distributions, and then I'm going to go into normal and NCD. And in here, I'm going to put this as variable. I'm going to go down to lower. Lower is 6, upper is 10.8. The standard deviation is 3.2, and the mean is 10.8. So what I'm going to do is I'm actually going to write the x values here like this, and at the z values I'm going to put it here, negative 1.406 and 0. Really, that should have been 0 unless I made a mistake. Did I put that as 10.5? There we go, that's why. That should be 10.8 because I know that the upper value should be 0. That's much better. So then the probability is going to equal 0.4332. What might be a good idea also to do is this step. So you might just write this step here, negative 1.406, Z and 0. Now this question is worth an achieved. Probability correct gets you an achieved. Yeah, and I just wanted to kind of reiterate that right at the top of the question, they say including diagram should be shown. So that's why I'm showing the diagram here. Okay. Part B, what we've got is our mean is still the same, which is 10.8, and our standard deviation is still 3.2. And what we're looking for is probability of x greater than 16. So if I was to draw a diagram here, this is going to be 10.8, this is going to be 16, and I'm basically going to be looking for this value here. So probability of x greater than 16 is equal to probability of z greater than. And what I want to do is I'm going to do the same thing, but except for my lower value is going to be 16 and my upper value, and this is the one people always complain about it, but I just go 1 times 10 to the power of, like, I don't know, you can put 100, okay, maybe not 100, maybe I just go 10. Yeah, let's try that. And if I do that, I actually end up with my probability of z greater than 1.625, and that's equal to 0.0521. Awesome. So that's just how to do this on the calculator. Now if you're going to do this with the manual way, I will be releasing a probability playlist very shortly. Hopefully I'll link it on the end of this playlist when it does come through. But yeah, I'll actually show you guys how to do this manually as well. But for now, this can be done in the graphics calculator, and that's going to give you another grade of achieved. All right, so the next question, it says 12% of all young people found to do less than the suggested amount. So that means we're looking at this part here is going to be 12% or 0.12. And our mean is still 10.8, and our standard deviation is still 3.2. So we need to figure out what the x value is. So what we can do is first we need to work out the z value. So you can actually do this question in the calculator, and I think you can do it straight away. if I remember correctly, because you just go into normal, you go inverse, variable Taylor's left, and that's going to be 0.12. And I think if you do that, you know, you already get the answer right there. 7.04 is the answer. However, we do need to show some sort of diagrams and workings to actually to get this. So what I'm going to do is I'm going to use the graphics calculator. Don't worry about it. So probability of capital X less than the little x, so that should be little x right there, is equal to 0.12. So I need to actually figure out, if I actually put this as a z value, then the z value is going to be 0.12. So I need to figure out what that z value is. And so to do that, what I'm going to do is I'm going to exit, and here the standard deviation I'm going to put as 1 and the mean as 0. And so what I get is probability of z less than negative 1.175 is equal to 0.12. So then we can do z is equal to x minus mean over standard deviation. So we're going to get negative 1.175 equals x minus 10.8 divided by 3.2. Now, if you are one of those folks that are kind of like a bit challenging with algebra, you could have actually done the inverse normal that we did before, except you would actually do it like this. So you'd actually go 3.2 and 10.8 to get the 7.04. All right, so your final answer is going to be something like this, 7.04. So I reckon you can actually do this where you can just go from this line to this line. But just in case you're like, I want to know this algebraically, we're going to go negative 1.175 times 3.2 equals x minus 10.8. And then we're going to get x is equal to 10.8 minus 1.175 times 3.2. So we're going to go into the main menu of the calculator, and we're going to try this out. I was trying something before and it didn't work out. All clear. Okay, so we got 10.8 minus 1.175 multiplied by 3.2. And as you can see, that's going to give us 7.04 as well. All right, so looking at this grades-wise, if you just gave the correct answer only, so if you just gave the 7.04, you'll actually get achieved. But if you actually show some evidence of working towards the formula, or clearly labeled diagram must be shown, that's going to get you a merit. Achieved also could be for getting this z value here as well. Okay, so next question. Okay, so for the second part of this question, what we've got is, okay, so it's a new distribution by the looks of it. So we've got mean of 8.1 hours. So we're going to write down mean as 8.1 hours. 5% of the students spend less than 30 minutes. Okay, which is 0.5 hours. So we can actually say probability of x less than 0.5 is equal to 0.05. So 0.5 is, I'm actually looking at 30 minutes, the 0.5 hours up here, and I'm keeping it in hours because the mean is actually in hours. So if you look at it, the mean is 8.1 hours, so we want to keep everything the same. So in this case, what we're going to do is, again, we're going to draw a very quick diagram here. This is going to be 8.1, we're going to get 0.5 here, and then the shaded region is going to be your 0.05. So once again, we're going to go into our calculator to figure out what our z value is. So distribution, normal, inverse. I've got left tail 0.05 and mean of 1 and 0. Sorry, mean of standard deviation of 1 and mean of 0. So that's going to give me a z value. So the x value is 0.5. Then the z value is equal to negative 1.645. So we've got z is equal to x minus mu over standard deviation. Now the z value is negative 1.645. The x value is 0.5 minus 8.1 for the mean divided by the standard deviation, because we're actually looking for the standard deviation in this case. So cross multiply, standard deviation is equal to 0.5 minus 8.1 divided by negative 1.645. So go into the calculator, and we're going to go 0.5 minus 8.1, and that's actually divided by negative 1.645. So that's going to give me a standard deviation of 4.62. So grades wise, this is one of those weird questions where it looks like a double, like both of these questions are linked up. So I'll actually do this part first. So for this part, correct negative z-score will get you an achieved. So getting achieved there. Correct standard deviation found with valid working gets you a merit. You could also get achieved only if you just put this 4.62, which I'm not sure how you'd get that, but yeah, you want to show some sort of working. All right, now the next part of this question is where you're looking at the excellence ones. Now it says, give 2 reasons why your answer in B1 suggests that a normal distribution may not be appropriate. Okay, now with this question, you've got to kind of think like a 15 to 17-year-old. I mean, if you really think about it, the first thing you would kind of say is that you wouldn't expect 15 to 17-year-olds to have a normal distribution, like symmetrical curve. So you might actually, and I'm just going to kind of put them as summary points here, folks. So the first one you can actually talk about is that the distribution is not, you can't say not, but you can say it's unlikely symmetrical. Because if you think about it, there's going to be symmetrical. I hope that's the right spelling. Symmetrical. No, it's 1T. Doesn't matter. Distribution is unlikely symmetrical because you're going to have a lot of kids that are probably doing a lot less activities, especially between 15 to 17. And at the same time, you also get like the real hard out ones, like, you know, where they practicing sports all the time. So they're always doing physical activities. So especially like, you know, if you think about people that are serious with club and then school sport on top of that, they actually tend to be quite physically active compared to someone that's, I don't know, like someone who games a lot. You know, they're probably not as physical, you know. So you could actually say something like that. You could also add like there could be a lot of students might be at 0, so it doesn't, a lot of students could be at 0 hours, which again means that it's not symmetrical. The other thing that you can talk about here is, if you remember, the mean was 8.1 and the standard deviation we found was 4.62. Now, generally speaking, if it, you know, this could not be normal. This could not be normal distribution because, generally speaking, like if you go 3 standard deviations above the mean and below the mean, you should have 99% of your data, or close to it. But in this case, within 2 standard deviations, you're actually going to go past 0. So this actually says that it's not going to actually work. Further to that, I mean, if you really want to kind of explore it, and I'll show you guys this. So if we go to, we go to distribution, right? And this is something like you can actually prove as well. Like if I go normal distribution and then I go lower is going to be negative 1 exponent 10. Like, no, not pi, times 10. And then I'm going to make my upper as 0. Standard deviation is 4.62 and the mean is 8.1. Now what I've actually tried to find here is I've actually tried to find what's the probability of less than 0. Now, if you think about it, probability of less than 0 is actually not possible because you can't actually have people doing negative time with their activities. But according to this distribution, it says that 0.39% of people, so it's basically 3.9%, are actually doing less than 0, which doesn't make sense. So you can actually say is impossible in this context. So that's a second reason that you can do. It's impossible in this context. And then another one that you could also do is talking about the 2 standard deviations. So 2 standard deviations is less than 0. 2 standard deviations is less than 0. And again, 3 standard deviations would give you almost a negative 5 hours. So this is another point that you can actually make as well. So for this question, I think the explanation does matter, and I know I've kind of summarized it here. For an excellence grade, you need correct standard deviation found from the previous question and one valid reason. So if you get one of these correct, you'll walk away with an E7. And if you get 2 of these that they feel that you've done a good job, then you actually get an E8 for it. That's pretty generous, to be honest. All right, so next question. Participation, blah, blah, blah. Survey investigates elderly people. 45% of the survey spent over 0.5 hours. So we got probability of X greater than 30. Sorry, less than 30. And not 30 years and over spent less than 30 minutes. So less than 0.5 is going to be 0.45. And then a mean is equal to 4.3. Now, let's say we actually draw this as a graph, right? Like, I mean, if you think about it, like, and I need you guys to imagine this, right? So let's say this is going to be 0, and then this is 1, 2, 3, 4, 4.3. So somewhere there is 4.3. That's 2, that's 3, that's 4. Maybe a little bit closer. There we go. That's 4.3 right now. Now it says probability of X less than 0.5 is 0.45. So you basically got 45% in this box right there. All right, so we can clearly see that this is not normal. And if your average is at 4.3, then you probably got something like a shape like this almost, where it's going to be like dragged out to the right. So you can actually say that distribution is not normal, and we can also say that lightly skewed and has a long upper tail. Cool. So achieved valid suggestion with comment on skewed distribution and achieved. And then let's go to part 2. Okay, so part 2 would say is when those adults 75 years spend no time in physical included. Okay, so it's something like this. Based on table and data display, approximately what would you expect the median number to be? Now the median number, I want to have 50%. So if I look at this right here, this is going to be 23%. So at about 149, we've got 23%. Over 420 is 40%. So they're around 420. So again, this is just a rough estimate, folks. So that's 40%. That's 23%. We want to know roughly where the median is. So now the answer schedule actually says that the median could be anywhere between this value, which is 150, to 419. They can basically say anywhere between that. But if it was me, I'm kind of looking at the dots here and trying to kind of get a gauge of where the middle is going to be. I would probably go somewhere around here is where the median is. So I can just say median would be around 300 to 320, for example. I looked at the answer schedule, and the answer schedule actually accepted from table would be around 150 to 419 minutes. It's a bit odd, that one, because it's like when I look at the answer schedule, the graph says 280 to 400. Yeah, it's kind of a weird one, because I looked at it as 25% there. See, I would have preferred an answer between 300 to 400 at least, but I reckon you'll be fine if you read it off the table there. So again, grades for that valid estimate for the median within the range of 280 to 400. Mine was between 300 to 320, so I'll be fine. But we've got to do at least one valid comparison of the feature. Okay, so this is one of those multiple questions. So I guess I'm going to have to go answer the rest of it. Yeah, I think I have to answer the next part of this question to get a merit. because this is still will be classified as achieved. Yep. Okay, cool. So part 2 of this is we've got to come out of these results compare to normal distribution with a mean of 7.2, standard deviation of 2.4, and briefly compare the center, spreads, shape, all of those things. All right, so we're going to do one at a time. First, we'll do the center. So the first thing about the center is when we look at the mean is actually 7.2 hours. Now, the first thing we want to do is we want to convert 7.2 hours into minutes. So when we do 7.2 times 60, that's going to give us 432 minutes. Now, if you go back and have a look at it, our median that we said was going to be between 150 and 419. That's definite. We know the median is between 150 and 419. That's the biggest range that we could actually look at. So we can say median is between 150 to 419. And because the mean is actually higher, so we can actually say mean is higher than the median. So that's the center. Next, we're going to have a look at the spread. When we look at the spread there, now standard deviation is 2.4 hours. So if standard deviation is 2.4 hours, we're going to do 2.4 times 60, which actually gives me 144 minutes. And now what we're going to do is we're actually going to work out what that 99% of the people are at. So we're basically going to go 7.2 plus or minus 3 times the standard deviation. Now, if I do 7.2 minus 2.4 times 3, I'm typing in the wrong area. So 7.2 minus 3 times 2.4. That's going to give me 0 to 7.2 plus 3 times 2.4. That's going to give me 14.4 hours. Now, 14.4 hours, I'm going to convert that into minutes. That is going to be 14.4. It's going to give me 864 minutes. And now what we're going to do is we're going to have a look at the data itself. Now, if you look at the data, we've got between 0 and roughly 800 and, well, actually, no, it's going from 0 to, what was the previous number? 864. I guess we can kind of say 864 is somewhere here. And so we've only got like one dot that's actually outside the range. And here we actually said that because when you do a mean plus 3 standard deviations, that's basically telling us that 99% of time spent is between 0 and 864 minutes. And we can kind of say this seems to match, this is matching the data above, matching the dot plot above. Not for the center, but for the spread, it definitely does kind of match it. And then we're going to look at shape. And this one is pretty simple because if you look at the mean, which is 432, 432 is somewhere here. And that's actually in the top 40%, which shows us that it's not symmetrical. And because it's not symmetrical, and we can almost say that there's a skew for this particular one to the right side, right? So we can kind of say that here. So we can say that the mean is in the top 40%, suggesting that it is not symmetrical, like a normal distribution would be. Okay, so that's pretty much, that's pretty much us covering this 3 different statements there. So for your grades in this one, giving one reason will get you a merit. And I think for a merit, you need to get the median from the previous question, which was that achieved question. And then one statement will get you a merit. But if you get the median right, and then 2 or 3 statements will get you a E7. Bit of writing for this one. But yeah, folks, that's pretty much it for this question. All right, so for question 2, what we've got is we've got to fill up all this probability tree first. So I'm going to start kind of doing things with a different color here so you can kind of see where everything is going. So firstly, I'm looking at the first bullet point, and we've got 35% that were aged 18 to 30. So that is going to be 0.3. and the rest were over 30. So what I've got to do is, sorry, that's 35%, not 30. So it's 0.35. So I've got to go 0.22 plus 0.35 equals to that. 1 minus 0.57. That's going to give me 0.43. The next branch, I've got 3/4. Where is it? So we've got, sorry, that's a bit tiny there. Let me just zoom that in. So we got 3/4 we're learning a language. And then while 15% was for travel. So if that's the case, and this is for under 18 years old, so that's going to be 0.15. So I've got 0.75, which is 3/4, plus 0.15 equals 0.9. So this is going to be 0.1. Then for the 18 to 13-year-old app users, 1/4 used it for academic purposes. So that's this right here. The 1/4 is using it for academic purposes, 0.25. While 60% used it to prepare for travel. So this is 0.6. So we got 0.6 plus 0.25 is 0.85. And if you do 1 minus that, you're going to get 0.15. Okay, I think that's pretty much, we've got everything we need for this probability tree. So going to part 1 of this question here, I'm just going to rearrange a few things. Give me 1 second. Okay, so part 1 of this question is asking, what is the probability that an app chosen at random is under 18 years old and uses it to learn a language for travel? Okay, so that's going to be, basically we're looking at under 18 and for travel. So that's going to be ending up with 0.22 times 0.15. That's going to give me 0.033. And I'm just going to write this here, probability of youth and travel. So that's going to give me an achieved grade. Next, what I've got is, sorry, just kind of moving around this, just trying to get that one big table. The next part of this question is, out of the selected group of 40 users, how many would you expect to be age 18 to 30 using the app for either academic or travel purposes? So what we're going to be looking at is, I'll just get rid of that one first. So how many would you expect to be aged 18 to 30 using app for either academic or travel? So we're looking at this branch plus this branch, and then we've got to multiply that by 40. So we're going to get 0.35 times 0.25 plus 0.35 times 0.6. That's going to give me the probability of 18 to 30 and academic or travel. So I'm going to work this out in the calculator, which is going to give me 0.35 times 0.25 plus 0.35 times 0.6. So that's going to give me 0.2975. And out of the 40 people, I'm going to go 40 times 0.2975. And that's going to give me 11.9. So I probably could say 11 users. I have to say 11 or 12 users. I'm actually going to go with 11 users. I never like rounding up, especially with probability questions. However, for the answer schedule, it does say that you need to have whole number to get a merit. So this number has to be either 11 or 12. If you got the 2975, you actually get an achieved grade. All right. The next one is part 3 of this question. Is we've got blah, blah, blah. The 3 times as many people use it for travel than other reasons. Okay, overall 55% of app users are learning languages for travel. Okay, let's have a look at this. So for this one, what we've got to keep in mind is we're looking at the over 30-year-olds. That much we know. So I'm just going to zoom up to here if possible. So the first thing that we need to keep in mind is that it actually says of the app users over 30 years old, 3 times as many people use it for travel than for other reasons. Okay, so we're going to create a new branch here where it's going to be for academic, travel, and other. Now, we don't know what that probability is, but all we know is like the travel one is 3 times as many as people for travel than for others. So if I put this as x here, then the travel one is going to be 3 times that, which will become 3x. Okay. Next, it says overall 55% of the app users, all ages, are learning use for travel. So I'm looking at this line here. But basically that means is that it's this branch plus this branch plus this branch here should equal to 0.55. That's the 55% there. So I am going to get 0. What is it going to say? I'm going to put this as probability of all ages travel. And travel is going to equal 0.22 times 0.15 plus 0.35 times 0.6. I'm just going to get rid of this equal here because I know that this is equal to 0.55 plus 0.43 times 3x equals to 0.55. Basically what I'm trying to do is figure out what that x value is. And I need that x value because what the question's asking is probability that given an app user is aged over 30 and are using for the with the probability for academics. So basically we're looking for this particular branch there. So let's actually work out what x value is. I'm just going to get rid of these pink lines because the pink lines is equal to 0.55. So I need to use the calculator for this. I've got 0.22 multiplied by 0.15 plus 0.35 multiplied by 0.6. That's going to give me 0.243 plus 0.43 times 3 is 1.29. So that's going to become 1.29x equals 0.55. So then I'm going to get rearranging this. 1.29x equals 0.55 minus 0.243. So 0.55 minus 0.243. That's going to give me 307. So 1.29x equals 0.307. And then x is equal to 0.307 divided by 1.29. And that's going to give me x value of 0.23. Well, actually, I probably should do it as 234. Now let's go 238. I don't know where I got 234 from. Okay, so if x is equal to 0.238, I'm going to go back to the tree diagram. So this x is 0.238. So if I go 0.238 times 3, that's 0.714. Then I can go 1 minus 0.714 minus 0.238. That's going to give me 0.048. So basically I could say that the probability of academic, well, given that they're over 30. Sorry, I just realized I'm doing level 2. So how am I going to write this? Probability academic given over 30 is 1 minus 0.238 minus 0.714, which equals to 0.048. Okay, so correct probability. Let's see what the grades are worth for this. Probability tree set up with 3x and x in the correct branches. That is going to be an achieved. Merit is correct algebraic equation set up to find x. Merit. And then correct probability for other or travel gets you an E7. So an E7 is actually to get the right values, the 714 and the 238. And then if you get the 0.048, you end up getting an E8. Okay, that's a lot of working there by me, but let's go to the next question. So now I think we're going to go back to the table by the looks of it, because it is estimated that 10% of the 18 to 30 year olds finish the course, academic purpose. 6% is the travel. Only 2.5% finish if they're learning the language for other reasons. Okay, so we're going to go back to the table here, because what we needed to do was, with the table, we're now going to extend that 18 to 30-year-olds as finish and not finishing. So for academic, it was 10%. So that's going to be 0.1. For travel, sorry, that should be F dash. For travel, it was 6%, so 0.06. And then only 2.5% for the other. So that's going to be 0.025. Now, the question is actually asking us, what is it asking? Where am I looking? What's the probability that if an age user 18 to 30 is chosen at random, they finish the course? Okay, so, well, the way I see it is I'm going to get rid of these colors here for now, because I know I'm kind of overloading it. If a user agreed 18 chosen at random, they finish the course. So we're basically looking at this branch, and this branch. And I probably shouldn't use pink. Terrible color. Let's go with yellow in this case. So age 18 to 30, and they finish the course. So it's all the ones where the branches have been put down. So what we should get is probability finish finish and 18 to 30-year-olds. So that's going to be 0.35 multiplied by 0.25 multiplied by 0.1 plus 0.35 times 0.6 times 0.06 plus 0.35 times 0.15 times 0.025. Right, putting this all in the calculator. Lots and lots of numbers. 0.35 times 0.25 times 0.1 plus 0.35 times 0.6 times 0.06 plus 0.35 times 0.15 times 0.025. That's going to give me a probability of 0.0227. Interesting. They've actually gone like 5 decimal places. Okay. That's all right. So we've got 0.0227, and grades wise, one of the correct probabilities is what an achieved, or all 3 extra branches shown on 3 is an achieved actually. And then merit for the final bit of this question for 0.0226. 0.2266. Well, I wrote it as 0.0227. That's fine. Moving on to the next question. Okay, so part B of this question is, according to the promoters, learners who buy the premium of 4.2. So that's a statement. So we're going to try and figure it out. 5% of the users install premium. So we're going to draw a quick tree here. So we've got premium and standard user. So premium is going to be 5%. So it's 0.05. 95% standard. And then they basically say that probability of users, standard user finishes is at 3.8. So finishes, not finishes. And so we're going to get 0.038. Not going to lie, this is actually a little bit tricky, this particular one, because it says it is estimated the probability of user chosen at random being a standard user and finishes the course. Right, so for this little part here, it's a little bit tricky because they actually say the probability of user chosen at random being a standard user and finishing the course is at 3.8%. So it's basically, you've got a question mark here. They have to actually go 0.95 times the question mark to get the 0.038. So we now need to figure out what that question mark is, because the question mark is they finish given that they're a standard user. So we're going to go 0.038 divided by 0.95. That's going to be 0.04. And then it says 4.2 times likely to finish the course as standard users for premium. So I'm going to multiply that by 4.2. That's going to give me 0.168. As that. Now I want to know what's the probability of finishing the course overall. So that's going to be this branch plus this branch. So probability of finishing course is equal to 0.05 multiplied by 0.168 plus 0.95 multiplied by 0.4. 0.04, sorry. So we got 0.05 multiplied by 0.168 plus 0.95 times 0.04. That's going to give me 0.99. Hang on, have I done something wrong here? I feel like I've done something wrong. Yes, I have done something wrong. I can see where I made my mistake. There we go. That's much better. 0.0464 is going to be the probability. So grades wise, probability of finishing for standard user found, that's the 0.04. So you get achieved for this part of it. And then for this part, you end up with a merit. Cool. Off we go to the next question. Right. So question 3A1, well, hopefully you've had a read through this, but what percentage of participants developed MCI? For which one developed MCI? I'm looking at foreign languages, I'm assuming. Oh, no, they're both the same. So it's 396 and... Okay, maybe I should have read the question properly. But that's fine. It's just what percentage develop MCI. So that's going to be 396 out of 964. So probability of MCI, 396, 0.4107 or 41.07%. Grades wise achieved for this question. All right, and for the second part of the question, we've got what is the probability that a participant developed MCI if they learned a language for at least some time, either 1 to 4 or 4 to 5 years. So this is an interesting one, right? Because we're looking for the people that have, what probability that the participants have developed MCI. So it's these two, if they learned a language for at least some time. So you've got to be looking at the 224 plus 42. So that's the guys that actually developed MCI from the group of 1 to 4 and over 4 years. So that's going to be the 576 plus 124. Yeah, so I'm going to say probability of MCI given they are 1 to 4 or over 4. Don't know why I'm writing like this. I should really just being lazy here. So probability of MCI given that they are 1 to 4 or over 4 years. So that's 224 plus 42 divided by 576 plus 124. So we got 224 plus 42. So that's going to be 266 divided by 700.38. So we're going to leave it at 0.38. Correct probability calculation of both probabilities is for an achieved. I guess you can kind of do this separately. If you did this separately, sorry, not like that. If you did the first one and then that one and then combine it, I don't think that'll work. So, but if you do that as separate, then you could get an achieved. 0.38 would actually get you a merit. Okay, part C of this question. Okay, so what we're going to have to do is we're going to have to look at the table first to develop MCI if they learn music for over 4 years, and then if they learn a language for over 4 years. So over 4 years, if we look at it, I think Susie's just looking at the values here, which is the 42 and the 85. But if you actually think about it, we've got 42 and out of 124 and 85 out of 258. So that's the proportions that we need to look at. So we've got, need to remember those numbers down. So 42 out of 124 and 85 out of 258. So 42 over 124 and then 85 over 258. 42 was language, musical instrument was 85. Okay, so the first thing we can be looking at is explain Susie's incorrect reasoning with valid conclusions. Okay, she could be looking at the numbers. So for starters, she could be looking at the raw numbers, which is 85 and 42. But probabilities for MCI with music, if learned music, over 4 years. So the music one was 85 over 258 which is, let me just have a look here, 85 divided by 258. That's going to be 0.329. And then if you have probability of MCI, if learned language over 4 years, now that's 42 out of 124, which is equal to 0.338, well, 339. So as you can see, when you look at the probabilities, these probabilities are actually pretty close to each other. So we can actually say probabilities close to each other. So Susie should say something like, chance of developing MCI is, developing MCI is very similar. Sorry, I'm just writing this in a short form. You guys need to make sure you write a bit more in your exam. Very similar for that. You could also calculate the relative risk. Again, if you calculate the relative risk, I think it's going to be very close to 1. Because if I do 0.339 over 0.329, 1.03, and if I do it the other way, 0.97. So it's not really very similar. So it's pretty much, you can kind of say that they're very similar to each other. And that's why she's wrong, because she's actually saying it's twice as likely. So grades wise, both probabilities given, at least one correct probability for music that's achieved. So achieved is either getting this one or this one. Both probabilities given and correct version of Susie's conclusion. So I guess we could say this. All of these three things should get you a merit. Both probabilities given, correct version of Susie's conclusion, incorrect reasoning explained based on raw numbers. So I guess this one is for your final E7 grade. Okay, C1. Right, I needed to actually bring the table back for this question here. So what we've got is relative risk, comparing the risk learned a musical instrument over 4 years who didn't play any music is 708. So if we have a look at this, what we've got is who learned a musical instrument over for 4 years. So that's going to be 85 out of 258. And then to those who didn't play any music, that's alpha out of 346 is 0.708. So basically what they're saying is, I'm just going to put down relative risk calculation here. So 85 over 258 divided by alpha over 346 equals 0.708. So got a little bit of algebra to do here. So I'm going to do 85 over 258 equals 0.708 multiplied by alpha over 346. And then cross multiplying, I'm going to get alpha is equal to 85 times 346 divided by 251 times 0.708. So then alpha is equal to, let me just work it out, 85 times 346. That is a fraction. Doesn't matter. It's fractions. So I'm getting 160. I made a mistake here. The answer schedule is saying something different. Let me just double check this. 85 out of 258. 258. Late in the night. 258, not 281. Much better. Alpha is 161. Okay, so that's going to give us this little value here as 161. And I think I'm done for this one. Correct numbers, but it must be a whole number. Yep, must be a whole number. So I've left it at that. So grades wise, 161 is going to get me a merit. The achieved is evidence of equation at 1 or 2. So basically, the achieved part is this right here. That's pretty much it for this question. But I think the second part of this question is connected. Maybe not. Anyway, here's the second part of the question here. All right, so for this question here, we've got a claim that we've got to kind of prove. But if we look at this, it says that either learning a musical instrument or a foreign language for over 4 years reduces the risk of developing MCI. So we're looking at by about 30%. So firstly, we're going to look at the relative risk for developing MCI. So MCI with music. Then we're going to look at the relative risk of MCI for languages. Now, with the music one, that's already given from the previous question, because that's actually given right here. Instrument for over 4 years who didn't play any music is 0.708. So that risk is already given. So that one we can say is equal to 0.708. Now 0.708 is roughly, what if I do 1 minus, let's just go 1 minus 0.708. So that's giving us 0.292. So that is 29.2% less likely for people who learn music to develop MCI. So that's for the music one. Now we need to do the language one. Now to do the language one, we actually need to go back to our original table. And if we look at it, we are looking at developing over 4 years, which is 42 out of 124. And then none is 130 out of 264. So 42 out of 124. So 42 out of 124 divided by, I think the other number was 130 out of 264. So 130 out of 264. This is the relative risk for MCI languages, 4 years and then compared to none. So we're going to do 42 over 124 and then 130 over 264. So that's going to give me a relative risk of 0.6878. And if I go 1 minus that answer, I get 0.3121. So we can actually say 31.2% less likely for people who learn languages. And again, I would put that languages to develop MCI. I think I probably should write that better. Who learn languages, I think probably did the same thing there as well. Who learn music for over 4 years compared to none to develop MCI. Again, same thing here. For over 4 years to develop MCI compared to none. Okay, now we've got the two relative risks. We've got 29.2% and 31.2%. And I mean, we can kind of say both are roughly 30%. And again, this is one of those questions where you can actually go either or either, because you can say, well, it's actually close to 30%. But you can also go, actually, no, it's not 30% because it's actually 31.2% and 29.2%. So it depends on how you write it. And by the schedule, it looks like accept either claims, as long as you kind of say one of them, you stick with one of them. So I'm going to go with both claims are roughly 30. Both claims are about 30% likely. So I'm happy with that. 30% less likely. So claim is valid. Okay, so grades wise, relative risk of calculating one of the relative risks is an achieved. This is an achieved here. Okay, relative risk for learning language is calculated but not interpreted or correct. Okay, so you need to is calculated but not interpreted. I'm thinking interpretation would be around the 31.2 and the 29.2 was it? Yeah, I think so. T1 is correct RR for learning language calculated. Yep. Interpreted 31% less likely. Yep. That's E7. Okay, I'm sorry, I'm actually getting that right. So if you get this part here, that's an E7. I'm not understanding what the merit part is. Language is calculated but not interpreted or corrected. Oh, right. Okay. So this is actually a merit here. But I think if you do it the other way, you could still end up with an achieved. So if you flip the probabilities upside down. And then finally, T2 is giving context and claim evaluated. That's going to be E8 there. Right. I think that's pretty much it for this question, folks. Now, cut scores for this paper. Cut scores for this paper achieved is at 8 points. As you can see, that's quite nice. Merit is actually quite nice, only 13. And excellence is 19. Fairly generous. I mean, I think very generous with the merit there to get a 13 for a merit. That's pretty awesome. But yeah, that's pretty much it for this paper. I'm not going to lie, folks. I mean, like, look, to be honest, I find the probability papers a bit of a drag because it just takes me so long to try and finish them. I think I started this at 9 o'clock and now it's like 10:30 and still trying to finish it off. But look, as for you guys, if you have any questions or comments, just drop it in the comment section below. Also, keep an eye out for the probability playlist that should be coming out soon, the actual skills, and I'm trying to do a probability in 10 hours playlist or 15 hours playlist. I think it'll be done in 10 hours. But yeah, keep an eye out for that. And also, don't leave anything empty in your exam papers. Good luck for your exams, and yeah, something should be popping up soon.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.